All right, hello lads. So we're going to have a look at some more exotic examples of complex numbers, hopefully to put your mind at ease. So imagine we have two complex numbers, u and v. And imagine, just for the sake of argument, that u times another complex number z is equal to v. How would I find z? Okay, so how would I find z? Okay, well, let's think about it. If these were three numbers and I knew this number, didn't know this number, but knew this number. So looking at 5 times something equals 10. How would I rearrange it to find that something? Well, when you just divide the 5 into the 10 to get that number. So in other words, you'd rearrange it so that z will be equal to v over u. So that's a typical type of really hard question, is where they give you this statement, you'll know two pieces of it. So you could write it out like this: 2 plus I times z is equal to minus 1 plus 2i. And then you're thinking to yourself, well, how do I get him on its own? Well, don't I move him over? And because this is a multiplication, when you move him over, it becomes a division. So that's really minus 1 plus 2i divided by 2 plus I. So once you got into the division mode, it should be easy enough after that. Remember our rules for division. We're going to multiply top and bottom by the conjugate. Okay, so the symbol for conjugate is a line across. So 2 plus I is u. So we were actually going to put down u conjugate. And what's u conjugate? It's change the middle sign. 2 minus I, 2 minus I. So now we have to multiply this out. So let's multiply this out using our little trick. To multiply out two conjugates together, you just square the numbers. That's just 2 squared plus 1 squared. Okay? Which is 5. Okay? Now let's do it the top line. Top line we have to do it traditionally. Minus 1 times 2 is minus 2. Minus 1 times minus I is plus I. 2 times 2 is 4i. And this is the tricky one. Plus by a minus is a minus. 2 times 1 is 2. But I times I changes the sign. So we're left with 0 plus 5i over 5. And of course, these will always be made so they divide. 5 into 0 goes 0 times, and 5 into 5 goes once. 0 plus 1i is your answer. So that's what z is. Okay, so that's a traditional hard one. At least it is for me. So let's have a look at some other ones. Okay, so hope you can see this one. So this is a standard one. There's always going to be some type of table. They've given you what Z1 is. They want you to write down Z1 and then Z1 with a line over the top. Now that means conjugate. So let's write down what Z1 is. Z1 is minus 2, minus 3, and because this is the I-axis, put the I there. Now, what's the conjugate of this? The conjugate of this is change the middle sign. Minus 2 plus 3i. So there's full marks. Now we need to plot and label Z1 conjugate. So minus 2 plus 3i, there's Z1 conjugate. So don't forget to do that bit. So look, that's full marks done. Now let's see the hard stuff on the next page. Okay, so Z2 and Z3 are two other complex numbers and they give you them. Plot them. So I'm going to go back now and plot Z2, which is minus 5 plus 3i. Okay, so minus 5 plus 3i, there's Z3. That one's done. And then the next one is that was Z2. Z2. And then Z3 is 4 minus 2i. 4 minus 2i, there's Z3. So I have Z1, Z1 conjugate, Z2, and Z3. Now, let's see what else they're telling me to do here. Okay? Subtract Z2 from Z3. So let's subtract them. Now watch, be careful when you're subtracting. Minus 5 plus 3i, there's Z2, minus. Now watch what I'm doing next. I'm putting a bracket and I'm putting the other one inside the bracket. Why am I doing that? Because that minus, you might attach it to the 4, but you might forget to do it to the minus 2. So let's work this out. Minus 5 minus 4 is minus 9. 3 minus 2, that's 3 plus 2, is 5i. Okay, now we're going to do the same thing again. Aha, look at this. They want you to do that, which I have done. And now what does these lines mean? These lines mean the modulus. And the modulus is a very simple thing to do. You just get the square root of these two numbers, put them in brackets and square them. Just the numbers. So get your calculator out. Square root of 9 squared plus 5 squared. I don't have to put the minus because I know it's always going to be positive. And that's 106. Square root of 106. Done. Now, what is the modulus? Well, the modulus is the distance between the center and that point. So, minus 9 and 5i, I don't think you can plot it. Now, investigate if Z3 is a solution. Okay, so we're going to look at this very carefully. If it's a solution, that means that I can multiply this by something else and get that. Now, usually, the way you check that something is a solution is use the minus b formula. But I would not use it here. Why? Because the minus b formula only really works when all the numbers are whole numbers. There's no I involved. So if that was z squared plus 2z minus 7, I could do the minus b on it and check that that's one of the answers. I can't. So the only other way to do it is to substitute it in. Everywhere you see z, you pop in this number. So that's what I'm going to do. 4 minus 2i squared plus 2i times 4 minus 2i minus 7i should be 0. So look, z squared plus 2iz minus 7i. So let's check this out. We're going to square this out. Okay, so how do we square this out? There's a couple of different ways. You can multiply it by itself, like this. So that's one way of doing it. So 4 times 4 is 16. 4 times minus 2 is minus 8. Minus 2 times 4 minus 8. Now be careful here. Minus by minus is a plus. 2 by 2 is 4. But because you're doing two i's, that plus becomes a minus. So let's do the rest of this. Plus 2 times 4 is 8i. 2 times minus 2 is minus 4i. Minus 7i equals 0. So let's see, does this equal 0? Okay, 16 take away 4, and there's nothing else I can take it away. That leaves you at 12. Well, I can't make 0, but anyway, we'll check. Minus 8 and another minus 8 is minus 16. Plus 8 gives you back to minus 8. Take away 4 is minus 12. Take away 7 is minus 19. And that's not equal to 0, so not a solution. Okay, now that's probably one of the hardest ones you can come across. Okay, so I'm going to show you another one. If I can find it. There we go. So, let's have a look at this one. Z1, Z2, that's all they've given you. So let's see what they tell you. If Z3 is Z1 plus twice Z2. So let's do that. Z3 is Z1, 1 plus 3i, plus twice Z2. So that's equal to 1 plus 3i plus 2 times 2 is 4, plus 2 times minus I is minus 2i, which is 1 plus 4 is 5, 3 minus 2 is 1. So there you have Z3. 5 plus I. Okay, now plot each of these points on it. Let's have a look and label them. Be careful, always label them. Z1, 1 plus 3I. There's Z1. Z2, 2 minus I. 2 minus I, Z2. And Z3, 5 plus I. 5 plus I. There she is over there. And there's Z3. And always make sure you label them, lads, please. Now, here we go. What does this symbol mean again? If it's side by side, it means it's the square roots, the modulus. Investigate. If I take away those two and get their modulus, it's equal to if I add those two and get their modulus. So let's do the take away bit first. Let's take away Z2 from Z3. Now watch, I'm putting the minus, then I'm putting the bracket because there's a minus, because I want that minus to work. So that's 2 minus 5 is minus 3. And that is... So we have 3 minus 5 is minus 3. Sorry, 2 minus 5 is minus 3. And minus 1i minus another 1i is minus 2i. So that's the first one done. So we're going to put that, wrap that in those lines. Now, is that equal to, let's do the other one. Let's add these two. 2, that's Z1 is 1, sorry, Z1 is 1 plus 3i, and we're going to add Z2. We're going to add 2 minus I. So 1 plus 2 is 3, and 3 minus 1 is 2. So, how do we do it? We get the square root, we take just the numbers, wrap them in brackets and square them, and add the answers like this. Is that equal to... Well, I can see already that it is, but I'm going to check it. The square root of minus 3 squared plus bracket minus 2 squared is root 13. And I know for a fact that this is going to be root 13 as well. And there you have it. Now, last bit. Find the complex number such that W, this new complex number, is equal to Z1 divided by Z2. So this is a straightforward one. We don't have to rearrange this. So W is equal to Z1. Z1 is 1 plus 3i divided by Z2, which is 2 minus I. So remember what we do, we multiply top and bottom by the conjugate of the bottom. The conjugate there is 2 plus I. 2 plus I. So let's do that. 1 times, sorry, we'll do the bottom bit first, the quick way. That's just going to be 2 squared plus 1 squared, which is 5. Surprise, surprise. Top line, 1 times 2 is 2. 1 times I is 1i. 3 times 2 is 6i. And 3 times 1 is 3. But because you got the i's, it's minus. So now what do we got here? We have, let me see. We have 2 minus 3 is minus 1. And we have 1 plus 6 is 7. So there it is. The first time we've ever done one where, look carefully, it's the first time we've ever done one where the answer doesn't cancel. So this answer is actually, so W is actually equal to minus 1 over 5 plus 7 over 5i. Bit of an unusual one.